Hello and welcome back. So in the last episode, we were discussing on software quality. Today I'm going to discuss on the real testing procedure. So first we'll move on to what is testing. So software is tested to uncover errors that were made inadvertently as it was designed and constructed. So when design and construction is done, there may be some errors which we cannot possibly identify at that time. So that for that we are doing the testing process. So here we have to put forward a strategy for software testing. So it is developed by the project manager, software engineers, and testing specialists. So let's see what are the strategic approach to software testing. So a strategy for software testing must accommodate lower level tests that are necessary to verify that a small source code segment has been correctly implemented, as well as high level tests that validate major system functions against customer requirements. So our first strategic approach to software testing can be done testing is a set of activities that can be planned in advance and conducted systematically, right? So for this reason, a template for software testing, that is a set of steps in which you can place specific test case design techniques and testing methods should be defined for the software process. So for this, to perform effective testing, we should conduct effective technical reviews. By doing this, many errors will be eliminated before testing commences. Now testing begins at the component level and works outward toward the integration of the entire computer-based system. So testing is conducted by the developer of the software, and for large project and independent test groups, different testing techniques are appropriate for different software engineering approaches at different points in time. Testing and debugging are different activities, but debugging must be accommodated in any testing strategy. So now our first strategic approach to software testing is verification and validation. This is shortly known as V and V. So verification refers to the set of tasks that ensure that software correctly implements a specific function, whether a specific function is implemented properly into the software. That is known as verification. And validation refers to a different set of tasks that ensure that the software that has been built is traceable to customer requirements. So validation is done whether the customer requirements have been properly implemented or have been properly carried out into the software. So V&V includes a wide array of software quality assurance activities, that is technical reviews, quality and configuration audits, performance monitoring, simulation, feasibility study, document review, database review, algorithm analysis, development testing, usability testing, qualification testing, and acceptance testing, and at the last and final installation testing also. Now, next strategic approach to software testing is organizing for software testing. So the software developer is always responsible for testing the individual units, that is the components of the program, ensuring that each performs the function or exhibits the behavior for which it was designed. Next, the developer also conducts the integration testing. That is a testing step that leads to the construction and test of the complete software architecture. Only after the software architecture is complete does an independent test group become involved. Then after that, the role of an independent test group, that is the ITG, is to remove the inherent problems associated with letting the builder test the thing that has been built. So independent testing removes the conflict of interest that may otherwise be present. So for avoiding these conflicts, we are integrating a group of independent testers. Okay, so that is ITG. Now our next strategy is software testing strategy, the big picture. For this I have shown a figure. The software process may be viewed as a spiral. Okay, here the figure is shown as a spiral. Initially, system engineering defines the role of software and leads to software requirement analysis, where the information domain, function behavior, performance constraints, and validation criteria for software are established. So moving inward, we come to design. See, after coding, we come to design. and finally to coding. Okay, so first system engineering, requirements, design, and then finally to the coding. Then unit testing. So while we move on to the other side, we have the unit testing phase. See, here we have the unit testing phase. Unit testing begins at the vertex of the spiral and concentrates on each unit of the software as implemented in source code. Then after unit testing, we move on to integration testing, where the focus is on design and construction of the software architecture. Then is the validation testing, where requirements established as part of requirements modeling are validated against the software that has been constructed. Then finally, system testing, where the system and other software elements are tested as a whole. So this is how it is done using a spiral model. But we can, considering the process from a procedural point of view, testing within the context of software engineering is actually a series of 4 steps that are implemented sequentially. This is how it is implemented. That is, we have testing, direction, code, design, requirements, and at the requirement stage, we are performing the higher order tests. Okay. Now, a strategic approach for software testing. Another strategy is criteria for completion of testing. Here we use the clean room software engineering approach, suggests statistical use techniques that execute a series of tests derived from a statistical sample of all possible program executions by all users from a targeted population. So we are using a series of tests with a statistical sample, and we are executing all these to a targeted population, and they will use this and they will say how the software is to be carried out. Now we have the next topic in this, that is strategic issues. So even we have the best strategy. We have introduced so many best strategies now, right? But even though we have the best strategy, would fail if we encounter a series of issues. Let's see what are the issues we are encountering. The first issue is specify product requirements in a quantifiable manner long before testing commences. So the objective of testing is to find errors, right? But it also assesses characteristics such as portability, maintainability, and usability. But this should be measurable in order to avoid ambiguity. That is, the software should be portable, maintainable, and usable also. Not only we are considering the errors, but also we consider all these factors which are measurable also. Okay. Our next issue is state testing objectives explicitly. So objectives of testing should be stated in a clear manner. That is, we should be very aware of what we are going to test. Then understand the users of the software and develop a profile for each user category. See, here overall testing effort can be reduced by focusing on actual use of the product and performing testing on the actual uses. Then develop a testing plan that emphasizes rapid cycle testing. That is, testing should be done in increments. Then we have build robust software that is designed to test itself. That is, anti-bugging techniques should be implemented. That is, diagnosing certain classes of errors. Okay. Then use effective technical reviews as a filter prior to testing, which means reviews can reduce the amount of testing effort. Okay. Then conduct technical reviews to assess the test strategy and test cases themselves. That is, technical reviews can uncover inconsistencies, omissions, and outright errors in the testing approach so as to save time and cost. Then the metrics. See, develop a continuous improvement approach for the testing process. That is, the metrics collected during testing should be used again and again. So we have to improve the approach for the testing process. Thank you so much. I hope today's episode was very clear.